Okay, so what I want to do on today's notes, guys, is I just want to have one place where we can have like a, a place kind of a reminder. So logical reasons in geometry. So that's kind of what we're going to talk about. So logical reasons in geometry. Okay, and then I want over here, I want non-logical reasons in geometry. So what we're going to talk about is we want to stick with our logical reasons in geometry. Okay? And then I want to talk about what are some things that aren't they're not bad, but they're not logical reasons we can use in geometry. Okay. So the first logical reason is what? What's our first logical reason, guys? The most obvious one is given, okay? And most of the time, you will not be able to do anything in geometry, any geometric reasoning without a given, okay? You cannot start from zero. You have to have some place to start. So a given is usually always mandatory, okay? You have to be given some information, okay? So that's the first logical reason. You can't start with nothing. You have to start with something. You have to set the stage before you can um, continue to logically reason through it. Okay. So the next kind of step was our postulate, right? Now, a postulate. Remember what a postulate is, and we've said this multiple times, is an obvious fact. Okay, and it should. And when you see postulates, you'll kind of say, yeah, it is obviously true that when two lines cross, they're going to only cross at a point. Or when we have a segment, we can measure it with a ruler. Or when we have an angle, we can measure it with a protractor. Or when we have what's another postulate? When we have two angles and that form a line, the two pieces equal the whole. You guys agree with that? Okay. So another thing we have is definitions. Okay. Okay. So if we say an example is for definitions, if the measure of angle, let's say A, plus the measure of angle B equals 180, then we can say that angle A is supplementary to angle B by definition. You guys understand that? So remember, supplementary, and so this is just a definition right here. Here's an example of us using a definition. We see that there are these two angles add up to 180. Then by definition, we can say that angle A is supplementary to angle B because that's what it means to be supplementary. Okay, and so we're going to have lots of definitions in here. We're going to define what we mean by congruent or define what we mean by supplementary. And whenever we see that happening, then we can automatically say we've done it and use that term. You guys understand what we're talking about here? Okay, now the big one in geometry. Okay, what we really are excited about in geometry are theorems. Okay, so this is really where we make our money in geometry. We don't really make any money in geometry, but as an expression, this is really where the fun happens is when with our theorems. Okay, so and a thing about a theorem is they require a proof. Okay, now I'm going to just kind of give you guys, once we start really moving into geometry, I may not have a proof for every single theorem. We may not do the proof for every single theorem. I'll try to do as many as possible, but especially at the beginning when we start to get into these theorems, I like you guys to be able to see the proofs because a lot of these proofs kind of follow the same, what do you call it, procedure. Okay, guys see that? All right. Now, another thing, another reason we have, and this would have been, again, if you're looking historically, this is a very recent development in geometry, is algebra. Algebra. So algebra is fair game. Anything we learn. So if we, everything from solving equations to factoring quadratics to graphing on the coordinate plane the distance formula, the midpoint, all that stuff that some of you said you forgot. We're going to review it, but it's all fair game. We don't have to actually relearn that. We're going to assume that we remembered every single thing from our Algebra 1 class, right? And we're going to be able to use that. Okay, number 6, I'm going to call them like cheats. Okay, so what are the cheats? The cheats are things that technically you shouldn't be able to use, but you can. What's the biggest cheat we can use in here? No. The biggest cheat, Sophia. The Pythagorean theorem. That's absolutely the biggest cheat. Okay, Pythagorean theorem is the most important theorem in all of geometry. Okay, you probably need to see a proof to that, but it's so important we actually say, well, we can use it. Okay, cheats. Pythagorean theorem is a cheat. Pythagorean theorem is a cheat. Area of basic shapes is a cheat. Area and perimeter of basic shapes. Okay, so if you want to find the did I spell that right? If you want to find the area of a circle, or the area of a square, or the perimeter of a rectangle, all of those things are cheats that we can use. Okay, and this is kind of a cheating category, I agree, but this is just the way the curriculum in District 11 allows us to do it. Okay, now the last one, I can't think of any more except for one more, and this is what we're going to focus on today, is constructions. Okay, so constructions are where we're going to focus on today. All right, so that's what we're going to be looking at today, is constructions. All right, constructions are like the OG of, the original. That's how the Greeks would have done a lot of their math, is with constructions. Okay, because constructions don't require any numbers. Greeks didn't have a lot of numbers. They more had just pictures and shapes. And so constructions is kind of like the old school way of doing geometry, but it's still a really good way to do geometry. Now, those are our logical reasons. There may be another one I can't think about right now, but pretty much I think that pretty much in any proof, usually you're going to be involving these. Now, and another thing, a couple of side things we talked about yesterday. If you're proving a theorem, you cannot use the theorem itself to prove itself. Do you guys understand that? You can use already proven theorems in your proof, but you can't use the theorem you're actually on. You guys understand that? So yesterday we were proving same side interior angles, right? Okay, we are absolutely okay. We could use the vertical angles theorem in there because we already know the vertical angles theorem and we have already proved it. But you can't use the same side interior angles theorem to prove the same side interior angles theorem. You guys understand that? That's a very common mistake. Kids want to use the actual theorem we're proving in the proof. You can't do that. Once you've proven it, though, then it's in your bag of things you can use for the rest of your life. Okay? Once you have a proof in it, that proof is solid. Okay, these proofs are solid. Once you got a proof, they are assuming that there's no we're assuming everything's good. Okay, now what are some non-logical reasons? Now let's start with just kind of like obvious things. Your feelings. Okay, if you feel good or bad about it, it doesn't matter. Okay, it doesn't matter how you feel about it. Okay, feelings. Observations are not logical. Okay, now I know in science, observations are big, right? In geometry, we don't really care about observations, okay, how it looks. Okay, we only really care about given information and logical reasons here. Okay, this is a completely different way of thinking. Okay, here's another one that you're probably going to be surprised about. Patterns. Okay, patterns. See how I turned patterns upside down over there? Because it is not good. That is not a good reason. Okay, just because something, think about it this way. If something is true 1 billion times in a row, that does not mean it's going to be true 1 billion and 1 times in a row. Okay? Now, is it most likely going to be true? Yes. Okay? Is it probably a good bet that you are onto something that's always true? Yes. But that's not a geometry reason. Patterns are not geometry. So geometry is not a pattern math. Okay, and And so the scientific method is not used in geometry. Okay, think about what the scientific method is. You look for a pattern, you look for something that reoccurs all the time, then you make a prediction, and then you test it. And then once you see that it does work after your experiment, then you say it's a theory or something like that, right? Or a hypothesis and then a theory. We don't do that in geometry. Okay, if it's not completely 100% true and you cannot logically prove it, we don't consider it. Okay, it's not a theorem, it's not a postulate. So it's very strict, because just because something has a pattern to it doesn't mean that that pattern can't change on the billionth time. Probability wise, you're probably, now human beings are pattern creatures. That's what we do, right? We look at patterns and then we kind of, our behavior, we change our behavior based upon that. So I'm not saying patterns are bad. Patterns are very good, but we're talking about geometry reasoning here. Okay, we're being very specific here. So we're not saying these are bad things. We're saying that they're not logical reasons in geometry. Okay, so you have to kind of shift your brain a little bit. Pictures are nice, but pictures are not proof. Okay, pictures can help us kind of understand things, but they are not. How something looks is not always going to be a logical reason. Okay. What else, Mr. Roden? Feelings, observations, opinions. Your opinions don't matter in geometry. Did I spell that right? No. How do you spell opinions? Opinions, right? Okay, opinions. Those don't matter in geometry. Okay, your opinion does not matter. Your feelings don't matter. Your observations don't matter. The patterns you see don't matter. Pictures don't matter. So it's not that I'm not saying that these don't matter in life. I'm saying when we're doing a geometry proof, those things do not matter. Cannot use them. They're not logical reasons. Okay, you guys understand that? Okay, which they're all good things, but they're not logical. They're not geometry. Okay, we good with that? So you're gonna have to put especially guys. How many of you guys are in AP biology right now? AP biology, guys. That's a lot of observation. That's a lot of patterns. Okay, probably a lot of feelings involved with you like those those animals and stuff, that living, but it has nothing to do with geometry. Geometry is a different creature. Okay, all right. Now let's talk proofs. Let's talk constructions. Okay, so constructions involve two tools. Okay, a construction involves two tools. It involves a straight edge and it involves a compass. Okay, now notice it does not involve a protractor. A protractor is a measuring device. A protractor is a nice thing you can measure things with, but it is not a construction. Okay, we like protractors in geometry because we can use the protractor postulate and measure things, but it is not a construction device. So what are the two construction devices? A compass, and this is not a ruler. Okay, you're not going to consider this a ruler. This is a straight edge. So I know this, if you look at it, it's a ruler, right? But when we're doing a construction, we're not going to measure. We're just going to create straight segments with it. You guys understand that? So we're going to ignore the measuring part when we're doing a construction. Now, can we measure in geometry? Yes. Okay, we take measures of segments all the time. Do we want to measure when we're constructing something? No, we do not. Okay, so how do we do this, Mr. Roden? Well, I'm going to tell you right now, the online tool is much easier than the physical tools. So we're going to start with the online tool because you're going to understand it a lot better when you don't have to struggle with the physical tools. Okay? So because a lot of it, your compass can slip, your pencil's not sharp, it takes some all those variables go out the door when we do a online tool. So here's what I want you guys to do. All right, so go to your Schoology page, and I should have the link there now. So go to Schoology, go into Geometry. Okay, go into Courses, Geometry. Okay, and it says construction tools. Okay, so this is a really cool program. And it's very simple. Now, the one thing that's terrible about this program is the pen tool, the writing tool is just absolutely trash. But everything else is pretty good. So I want you guys to play around with this a little bit. Now, here's the deal. A protractor, we said, is not a construction tool, but we can use it if we want to measure something. So it does have a protractor in there, but we're not going to, when we're constructing, we're not actually going to use the protractor. Okay, the ruler, we have a ruler here, but we can also use it as a straight edge. Okay, you can hit your pen, you can draw a line on it, draw a line, it'll draw a straight line. See that? So you guys can play around with that for a minute. Okay, also we have, the one I like a lot is the line maker tool. Okay, that is because it's a line maker tool, we can assume that's just a straight edge also. You guys understand that? And the big one, the one we're going to use a lot, is the compass. Okay, now let me just kind of show you some things about the compass. If you want to make a dot point, you just go to the compass and click it one time on the black part of the compass, move the compass around, and it'll give you a nice dot. You guys understand that? That's the best way to make a dot point, is to just tap the top of the protractor, the compass. All right. Now, if you want to actually draw something, if you just grab the left part of the purple part, you can move it around. Okay. If you actually want to draw let me clear this all out. Let me delete this all out here.
I can't get in.
You can't get in?
Yeah.
Has anyone gotten in yet?
Yeah, I have. I have a lot of fun.
Yeah, I don't know. Do me a favor, go back out, go back in. I don't know. I have no idea what you can. Are you?
No, why are you?
Okay. Let's see here. There's some new stuff down here. What is this? Okay, rectangle. What's this? Oh yeah, this is brand new stuff. They added some stuff on. That's cool. Okay, and then stickers. I guess you could put stickers on there. Who would ever want to do that? 100%. Who would want to do this? This is just stupid stuff. Okay, this is brand new stuff that I have no idea. Why would anyone want to put a smiley face with hearts on their construction? Okay, anyways, clear screen. Clear screen.
What? Come on.
Okay, all right. Okay, this is just ridiculous. Why do I have this? I can't even get out of this stupid thing now. What is this? This isn't even part of the construction. What happened?
There's not. Oh, it's your Screencastify. It's not the website. It's the Screencastify.
So what do I do?
Click on your screen.
What?